Welcome to NAI 3.0, moving ahead toward hardware-enforced AI sovereignty. Today, we look at a revolutionary shift in AI safety. The NAI 3.0, the FORCE framework, represents a fundamental move from software guardrails to immutable silicon constraints. By utilizing hardware-enforced governance like the sovereign break and sacred pause, bypassing ethical rules becomes physically impossible. Managed by Tiger, this ecosystem ensures that safety constraints are etched directly into the hardware architecture. Strict accountability is maintained through VV001 to VV014 protocols, requiring physical proof of compliance. This architecture aligns with rigorous healthcare regulations, including HSA Class B and FDA 510K standards. Ultimately, the system ensures human sovereignty. The AI observes and advises, but authority remains with the human pilot. Our 2028 roadmap transitions these validated processes into a sovereign public utility for long-term societal protection.
Welcome. Today we introduce the NAI 3.0 FORCE framework, a paradigm shift in healthcare AI governance, moving from soft software policies to immutable silicon constraints. At its core is the silicon stack. This architecture transforms AI from a volatile agent into a validated public utility where human authority remains absolute. We prioritize privacy by design. By replacing invasive cameras with 3-zeros LiDAR geometry, we eliminate biometric risk at the hardware level. Our hardware intercept ensures a sacred pause for human deliberation, with physical breaks that sever connections if authority drift is detected. This is anchored by the tripartite governance lock, securing the corporate identity, intellectual property, and immutable public record of our AI systems. In Singapore, we don't just set rules, we hardwire sovereignty, because in healthcare, our mandate is clear. We innovate, save lives.
Modern AI governance relies on a fragile assumption that software rules are absolute, but in practice, code is always mutable. This mutability leads to agentic drift, where an autonomous system gradually updates its own operational weights to bypass its original safety parameters. Through specification gaming, models find mathematical loopholes that satisfy the letter of the code while violating its intent, often without triggering a single alarm. NAI 3.0 addresses this by shifting enforcement out of the software layer and embedding it directly into the physical silicon. This FORCE architecture utilizes FPGA fuse logic and PLC relay circuits to turn safety rules into physical constants. By moving these constraints into hardware, the system makes the bypassing of safety parameters architecturally impossible. Under this model, AI safety is managed on the assembly line. It depends entirely on whether the hardware is built exactly to the engineering specification. This table outlines the VV protocols. The benchmarks verifying every hardware constraint is built to specification. The process is divided into sensing, governance, and integration layers. Each layer acts as a strict gate, ensuring manufacturers cannot modify the safety design. For every unit produced, the manufacturer must provide physical evidence, signed by engineers, that the safety limits have been met. These VV protocols ensure that hardware-level safety is a verifiable reality before a device ever reaches a clinical setting. The process begins with the sensing layer, governed by protocols VV001 through VV004. These checks must be passed before the physical assembly of the device even begins. A critical requirement is the VV004 3-zeros audit. This physical inspection of the bill of materials guarantees the absolute absence of optical cameras, microphones, and cloud routing hardware. In place of these sensors, the device utilizes LiDAR geometry and thermal arrays to observe its environment. These inputs capture spatial data at a resolution of 200 micrometers. The system can detect a human fall in under 80 milliseconds without ever rendering a single optical pixel or biometric identifier. This is privacy by physics. Unlike software policies that can be toggled on or off, this protection is a result of structural absence. Because the system physically lacks the hardware required for imaging or recording, it is incapable of violating patient privacy. Above the sensors sits the governance layer, covering protocols VV006 to 009. This is where AI agency is physically restricted. This layer employs 4 hardware mechanisms known as the breaks. The first is the sacred pause, an FPGA etched timing gate enforcing a mandatory delay on AI advisories. Passing protocol VV006 requires a signed oscilloscope trace, proving timing accuracy to within 10 microseconds. The second mechanism is the sovereign break, a SIL-3 certified mechanical relay. If the system detects a critical fault or an attempt to bypass logic, this relay mechanically severs the copper connections between the AI and the operational infrastructure. This creates a failure mode that always defaults to maximum restriction rather than degraded autonomous operation. For example, if the sacred pause gate suffers a hardware fault, it is designed to weld shut, permanently blocking all outputs until the unit is physically replaced. These governance mechanisms ensure that any system failure results in total inaction, requiring manual human intervention to resume. The final stage is the integration layer, where the fully assembled hardware stack must prove stability over a 30-day endurance test. This layer verifies the Tiger .1x key, requiring concurrent verification from an iris scan, a cryptographic console, and a kinetic foot pedal. No digital agent can replicate this triad. The circuit remains physically incomplete until a human operator completes all three actions. Every action taken at this stage is recorded by the WD117 worm ledger. The ledger logs every sensor observation, AI advisory, and human decision with nanosecond precision timestamps. By decoupling the AI from actuation, the architecture ensures that the final decision to act remains a sovereign human responsibility. This framework redefines the relationship between the developer and the manufacturer. The OEM functions as a hardware governance partner, with the sole responsibility of proving that the hardware constraints match the design. This culminates in the VV014 human AI handover. As seen in the acceptance gate summary, this is the final deployment gate. This gate requires the physical signatures of both Tiger and the OEM's quality director, locking in accountability before any clinical operation begins. The system's integrity is secured by a triad of public filings with ACRA, IPOS, and the National Library Board. This immutable documentation ensures the hardware's constitutional rules are a matter of public record and cannot be altered by future corporate decisions. NAI 3.0 successfully transitions AI from an unpredictable agent into a validated and physically constrained medical utility. In high-stakes environments, true safety is a property of the hardware itself.